I hope you enjoy our video on how to install a QFN using the solder bump method.
Hello. Today we're going to demo our chip-off 600 BGA Rework Station. This is an entry-level BGA Rework Station that has a split vision system that allows you to look at the PCB pads and the component pads so that you can line them up and have accurate placement. This particular machine has top hot air, bottom hot air, and infrared area heaters to heat up the overall PCB. And this helps when you have boards that may warp. If you heat up the board more, you will require less heat on the area heat, on the spot heaters, and it'll reduce warpage. So on this particular board we're working on today, it has a small chip. It's about 10 millimeters. And normally we'll just use if we have a 10 millimeter chip, we'll use about a 2 to 4 millimeter. I just use like a 12 to 14 millimeter nozzle on the top. And on the bottom we usually use a larger nozzle to heat up as much of the board as we can to compensate for heat differential. This particular board was warping when we used a smaller nozzle. So we increased our top nozzle from a 12 millimeter to a 28 millimeter. And this will allow us to heat up more area of the board, which will reduce the possibilities of warping. Also with the area heaters, we increased the time on the first zone to allow the board to come up to about 90 C. So we're preheating up the board more, and that'll help reduce the differential on the heat and reduce warpage also. That's just a brief overview of what we did on the profile. I'm going to do another video later on profile development. This machine here has split vision with upper and lower lighting, so you can adjust the lighting for your vision, so what looks better, what looks best for your eyes. It has a joystick that'll move the head up and down, and also allows you to zoom in and zoom out. And then it has a software to allow you to program up to 8-zone profile. And again, on this video, we're just going to go over the machine features and how to remove a component. And then we'll do another video with a close-up on how the software operates. But for now, what we're going to do is we're going to take off this chip. We've already created a profile. And again, for this particular board, it was warping down a little bit. And so when boards warp down, you'll usually use less bottom heat, more top heat. If a board warps up, you use less top heat, more bottom heat. But most boards you use even top and bottom. So most boards, when you initially set up a profile, we'll just make the top heat and bottom heat even. And if we have any warping issues, we can adjust our profile to compensate for the warping issues. So for this one, I put a bead of tacky flux around the chip already, and I've attached our external thermocouple towards the edge of the chip. So what we're going to do is we're going to follow the vision system here. And we're going to make sure that the pickup tube is aligned around the component. So our top light, which is the pickup tube on the nozzle, are in blue, and the board is in a gold color. So we have two different colors, so when we get ready to line up the component, we can differentiate between the component pads and the PCB pads. So we're lined up, the pickup tube is centered on the component. What we're going to do is we're just going to hit the toggle switch. And it's going to go down. We have an external light here, we can turn it on. And you can see that it stops reloading for the component. And so it's going to stop a little bit above the component, and we're just going to take the toggle switch and move it down. And we want about a 2 millimeter to 4 millimeter space between the pickup tube and the component. Once we've got everything where we want it, all we're going to do is we're going to press run. And this is going to run our profile. I'm going to watch the external thermocouple. I want to see a temperature of around 235 to 250. That's what it's going to take to melt the lead-free solder and make it become liquidous. At the end of the profile, the machine is going to beep, and we're just going to manually move down the joystick. It's going to activate the vacuum, and we'll pick up the chip. With the current curve here, we're in zone 2 at about 190, and our peak zone is going to be about 280. If you look at the test temp here, that's their external thermocouple temperature. Right now we're at 155 at the component, where the board's at about where the heat on the machine is about 175. Approaching the third zone, we're going to go up to 220. So we want to concentrate on here as we're going to look at our upper temperature and our test temperature. So our upper temperature on the red on the upper left is what our upper heater is putting out. And our test temperature in blue on the lower right, the top screen, is 170. That's what the thermocouple is at the edge of the chip. And again, at the edge of the chip, we're probably going to be looking for about 235 to 250 before we become liquidous and lead-free. Okay, so we're approaching our fourth zone, it looks like. I think our fourth zone. Let's go back. Yeah, our fourth zone is going to be 250. So look at the upper red. I'm reaching 250. Our test temperature is 193. Moving on here, we're going to our fourth zone. Look at our current curve. Our fourth zone is at 250. It's going to hold it for 40 seconds. When our fourth zone, top heater 250. Remember, we're keeping the bottom heater is lower than the top to reduce the board warping down. So far, we have no warping on the board. It looks really good. And we're at 250, and our external temperature at the QFN is 223. And we want to get about 235 to 250. So our last zone, we press current curve here again. Our last zone is going to be 280, so we should be good. So we're approaching liquidus, so about 250 at the component. We're in our peak stage. We've adjusted to 280 on the top, 270 on the bottom. Wait for the machine to beep. Okay, we're beeping. We'll move the joystick down. Wait for the vacuum to go up, down, and on, and pick up. Nice. About 250 exactly at the side of the component. Since this particular component does have a ground pad in the middle, we're going to need a higher temperature on the perimeter to get that to melt. This profile looks like it's dialed in now, and the cooling fan's hooked up. Wait for it to cool off. And basically, we're going to get our little plate here. And what we'll do is we'll put this on the component, push up on it, and that turns the vacuum off and releases the chip on the plate. So that's our removal process. And then next video, we will do the installation process.
So here we have a new chip that we have coated with Tachyflux. And then we added some solder balls that are about equal to the width of the pad in size. We're going to add a few more balls to the center. And then we're going to heat the chip up with some hot air and melt the balls to the pad. Here we see what the chip looked like after we reflowed it with hot air. We added enough solder on the center pad to be about equal height as the outer balls. Next, we're going to clean the chip off, and then we're going to get ready to place on the circuit board.
Okay, so now we're ready to install the chip on the board. And again, we're doing a QFN type chip. This chip has a double row of pads underneath with the grounding center pad. And most QFNs, they only have a single pad around the outer row. So if you don't get enough solder on them, you can always place them and then touch up the outer rows with a solder gun afterwards if you're in a hurry. But with the double row QFNs, we like to do make sure we have a uniform amount of solder on the board. So in this particular instance, we use solder balls to bump the chip before we install it. You can also get a stencil and solder paste, the paste on the board, and then reflow the chip to create bumps before you install it. And so like I said, this one here we already put solder balls on. I showed you earlier in the video. So now I'm going to show you how to pick up an alignment. We've already fluxed our board, so we got some tacky flux on the board. I hand placed the chip here and just lined it by hand under the microscope before I put it on. And I've got a thermocouple on the bottom side now because I don't want to interfere with the balls, but I just want to monitor my temperature. So what I'm going to do is I'm going to pull out the vision system. Wait for the autofocus to kick in. I'm just going to zoom out here until we can see our component. Again, we have upper light for the pickup tube in here. We have lower light for the circuit board. And we want to adjust our upper and lower light so that the autofocus will work smoothly. So now I'm going to zoom in. I can increase my upper light so that I can see the pickup tube more here. And I can move my pickup tube up and down a little bit to help it focus better. So normally you want to bring it down a little bit so it focuses better in the screen. I can use my micrometers, left, right, up and down to align the component. So the pickup tube is lined up to pick up the component. Zoom back out. Make sure that our nozzle here is not going to touch these components on the side. And when we get ready to place, we'll zoom in and give you a little bit close up on the video screen. Right now I just want to show you a little bit visual on how to use the controls. So I'm just going to hit down on the joystick. I have it set on semi-auto mode on the touch screen. And it'll go down and I have it set to stop just a little bit before the chip. And turn on the outer light, and then I'll move it down the rest of the way with the joystick until I hear the vacuum turn on. So the pickup tube touched the chip, vacuum turned on. Want to make sure that the vacuum is on. Then we can move back up until it stops. So just hold on to the joystick until it stops moving. Let go of the joystick and then hit it up a second time. It'll move all the way up automatically. Turn off your external light as not to interfere with our lights on the vision system. Now what we're going to do, we're going to open the vision system and wait for autofocus. If autofocus doesn't come in right away, you just zoom out and then zoom back in. So now I'm going to zoom in. And what I'm going to do, I'm going to use the zoom in, zoom out control on the joystick and the up down control on the joystick to move the head up and down. Because what happens is the board we're going to the autofocus focus on the board, but to focus the chip we have to move the head up and down a little bit to fine-tune focus on the chip. And as you move the head up and down, you'll notice that the pads will stretch in and out. They move in and out because of the curve of your camera tube. And what we're going to do, we're going to move in close and we're going to line up our pads on the chip to the pads on the board. So joystick, now let's go ahead, I'm going to zoom in here and we can watch on the camera.
Stay tuned for part 2. Don't forget to like, subscribe, and share. Thanks for watching.